Today I want to show you something that almost nobody talks about, but that could change the balance of the entire planet. There is a mountain range the size of a whole country hidden beneath the ice of the Arctic. And it is not just a geographical curiosity. It can influence Europe's climate, interfere with global ocean currents, unlock billions in oil and natural gas, and it sits at the center of a silent dispute between Russia, Canada, and Denmark. And the most intriguing part is that it should not even be where it is. This is the Lomonosov Ridge, and after this video, you will never look at the Arctic the same way again. Let's start from the beginning. The Lomonosov Ridge is a gigantic underwater mountain chain that stretches across the Arctic Ocean. It begins near Siberia, passes close to the North Pole, and extends all the way to Greenland and Canada. It is approximately 1,800 kilometers long. To give you perspective, that is farther than the distance between many major cities across large countries. And all of this lies hidden beneath permanent ice. It rises up to 3,700 meters above the ocean floor. Yet its highest points sit less than 1,000 meters below the surface. In other words, it is a colossal submerged mountain range. But what truly makes it remarkable is not its size. It is the type of rock it is made of. Most underwater mountain ranges are formed by volcanic activity. The Lomonosov Ridge is not. It is made of continental crust. That means it is essentially a fragment of a continent stranded in the middle of the ocean. And that is unusual, because continents are not supposed to be isolated in the middle of the Arctic Ocean. So what happened? About 55 million years ago, the tectonic plates of Eurasia and North America began to separate. When that happened, a fragment of continental land became isolated. That fragment eventually became this ridge. It is literally an ancient piece of land that was left behind when the ocean opened up. Now think about what that means. If it is continental crust, it carries sediments, geological layers, records of the past. And this is where the story becomes even more fascinating. Scientists drilled into the ridge and found sediment layers nearly 5 kilometers thick. These layers preserve climate records that go back millions of years. And do you know what they discovered? There were periods when the Arctic was warm, ice-free during summer, and full of marine life. This is important because many people assume the Arctic has always been frozen. It has not. But here's the crucial point. Those ancient changes happened over millions of years. What we are witnessing today is happening over decades. And that is where this ridge becomes even more significant. It is not just a record of the past. It influences the present and may shape the future. Now let's move into something few people fully understand. The Lomonosov Ridge influences ocean circulation, and that is enormous. The ocean is not still water. There is a global system of currents known as thermaline circulation. It works like a massive conveyor belt, moving warm and cold water around the planet. This circulation helps regulate Europe's climate, keeps temperatures milder than they otherwise would be, and distributes heat globally. The ridge acts like an underwater barrier. It redirects how cold, dense water sinks and moves through the Arctic. If that dynamic changes, it can affect circulation in the North Atlantic. And if North Atlantic circulation weakens, Europe could cool dramatically. This has happened before. Small shifts in freshwater and saltwater flows have altered entire climate patterns. There is also a phenomenon as the Beaufort Gyre. It is a massive whirlpool of fresh water in the Arctic. This fresh water accumulates at the surface and prevents warmer waters from rising. It acts like a lid. The ridge helps define the boundaries of this gyre. If the system becomes unstable and releases large amounts of fresh water into the Atlantic, it could interfere with the Gulf Stream and change climate patterns across the Northern Hemisphere. In other words, this invisible mountain influences global climate systems, and we are not done yet. The ice above the ridge also plays an important role. Large blocks of sea ice become trapped in the elevated topography of the ridge. This ice reflects sunlight. Reflecting sunlight means cooling the region. But satellites show that this ice is thinning rapidly. Less ice means less reflection, more heat absorption, more warming, and more melting. It is a self-reinforcing cycle. And as the Arctic warms, it becomes more strategically important. Because beneath the ice lie vast resources. It is estimated that the Arctic contains around 13% of the world's undiscovered oil, and nearly 30% of its undiscovered natural gas. Much of it lies beneath thick sediment layers, including areas around the ridge. And this is where geology turns into geopolitics. According to the United Nations Convention on the Law of the Sea, a country can extend its exclusive economic zone if it proves that a submarine formation is a natural extension of its continental shelf. 3 countries are trying to prove exactly that: Russia, Canada, and Denmark. Each claims that the Lomonosov Ridge is an extension of its own territory. In 2007, Russia sent a submersible to the floor of the Arctic Ocean and planted a titanium flag beneath the North Pole. It did not change anything legally, but symbolically it was a powerful message. Since then, Russia has expanded its military presence in the Arctic, built bases, increased patrols, and invested in nuclear icebreakers. Canada and Denmark responded with scientific missions and formal territorial claims. And why has this become even more relevant now? Because the ice is melting. As the ice retreats, new shipping routes are emerging. Routes that significantly shorten travel time between Europe and Asia. Less time means lower costs, less fuel consumption, and greater commercial efficiency. Whoever controls these routes controls part of global trade. So this is not just about oil. It is about strategic influence. The Arctic is no longer an irrelevant frozen desert. It is becoming a geopolitical chessboard, but studying all of this is not easy. The Arctic is one of the most challenging places on Earth for scientific research. Extreme cold, months of darkness, thick ice, and the difficulty of installing permanent sensors make it incredibly complex. Even so, scientists use icebreakers, sonar mapping, autonomous underwater vehicles, and deep drilling to better understand the ridge. Each expedition reveals more layers, more geological faults, more evidence of past activity, and more questions about the future. And this is where the story grows even bigger than oil or territorial disputes. The Lomonosov Ridge may be one of the keys to understanding how the Arctic will evolve in the coming decades. If the ice continues thinning, if ocean circulation shifts, if the freshwater gyre becomes destabilized, the impacts will not remain confined to the Arctic. They could affect the global climate. And all of this is happening now silently, beneath the ice, far from the eyes of most people, yet deeply connected to the future of the planet. Perhaps that is the greatest lesson of this story. Sometimes the most important structures in the world are invisible. They do not appear in headlines every day, but they shape entire systems, climate, economy, and geopolitics. The Lomonosov Ridge is not just an underwater mountain range. It is a point where science, energy, climate, and power converge. And what happens there may define the next era of the Arctic and perhaps the balance of the planet itself.